In this video, we're going to be focusing on creep, which is the time-dependent deflection of timber. And to illustrate it, we've got a small experiment. We have one unseasoned piece of timber, which is quite damp, and one seasoned piece of timber, which is quite dry. We're going to load them up and then measure the deflection over a period of time. And we're using house bricks to do it. The deflection can be measured by measuring the distance off the tabletop. So first up, using the unseasoned piece of timber, the distance from the tabletop is 91 millimetres. And for the seasoned piece of timber, 87 millimetres. And we'll monitor these over the next 2 hours. After 5 minutes, we repeat the measurement. For the unseasoned timber, 89 millimetres. For the seasoned timber, 85 millimetres. After 15 minutes, the measurements are for the unseasoned timber, 87, and for the seasoned timber, 84. After 30 minutes, the measurement for the unseasoned timber is 82. Wow, it's really moving. And for the seasoned timber, it is still 84. So by now we're starting to see that there is more creep in the unseasoned timber than the seasoned timber. After 60 minutes, for the unseasoned timber, we have 79 millimetres. And for the seasoned timber, we have 84 millimetres still. So at this stage, the unseasoned timber seems to be deflecting over time, but the seasoned timber seems to have stabilised. It is now 2 hours since we first loaded these two pieces of timber, and we'll take our final set of measurements. First up, for the unseasoned piece of timber, it is now 75 millimetres. And for the seasoned piece of timber, it is now 83 millimetres. So over the 2 hours, the long-term deflection in the front piece of timber, the unseasoned piece of timber, was higher than that in the back piece of timber, the seasoned piece of timber. The seasoned piece of timber has got less moisture in the microscopic structure than the unseasoned piece of timber. So the higher moisture content in the unseasoned piece of timber lubricates all of the fibres so that they can slide against each other slowly over a long period of time. Thus, when the timber is loaded, the compression timber on the top is able to move a little bit, maybe even wiggle and buckle a little bit if it's lubricated by moisture inside the timber structure. So in a real structural system, when we apply loads, we get an instantaneous elastic deformation. Over a period of time, timber is going to creep a little bit more. That creep deformation is going to be much larger if there's moisture in the timber, if the timber is unseasoned when we start off. We get even bigger creep movements if the moisture content of the air is changing all of the time. And we might see that kind of environment in a swimming pool structure. Creep is very important to consider in an environment where there's high moisture content or the moisture content is changing. But this experiment has shown us what creep can and does do for timber in structures. It can be taken account of in design, and it is the J2 factor in design that enables us to account for creep.